Okay, so now what about the next example? It's not a simple step function. We have step function of 2x plus 1. Well, guess what? You should be very good with function notation by now, right? So you do 2 parentheses plus 1, right? Again, always use parentheses when you do functions. Always do parentheses when you do functions. And we have 2 times, oh, sorry, I should put 0.4 right here already. So you have a little 0.8 plus 1. Okay, you don't need to do step function. You don't need to process the step function until the very last moment. So you have the step function of 1.8, and that means you have the number 1 as the answer. Easy? Okay. All right. Try next one on your own. Okay. How would you do if you have 3.2 as your x value? Okay, what's 3.2 in this case? G of 3.2 would be step function of 2 times 3.2 plus 1, okay, which is 6.4 plus 1, which is step function of 7.4. And that is just number 7. That's the answer. Okay. And then do the same thing for g of -7. We say step function of 2 times not 0.7. It is -0.7 plus 1. Okay. And that is -1.4 plus 1, which is -0.4. And then the final answer is -1, not 0, -1. Okay. So if I were you, I would just do something to remind myself that whenever that's negative, it is very, easy to make a mistake. So you remind yourself not to make a mistake over there whenever you see negative. Okay. How do you feel? Easy? Pretty easy, right? Okay. So now what about the graphs? Okay. Now let's see how well you retain your graphing knowledge from last year. Now, if you have a +1 right here inside, what does that mean? Which direction does the graph shift? To the left, okay? So inside it is +1, meaning that it's -1, okay? In case you wonder why it is to the left. So we say it is shifting to the left 1 unit. So now if you know what's going on, then you say, oh yeah, originally it's like this, but now it's shifted to the left. So then you'd be like, oh yeah, so I just go ahead and start. But now, this is where you practice. This is where you practice critical thinking. How do you know that you are right? How can you confirm that you are spot on? Huh? You can use a table or just plug in a number, right? Plug in like a 0.5, for example, okay? So let's just say x is 0.5, okay? X is 0.5, so you have step function of 1.5. So that means when x is 0.5, your y value should be 1. And it is 1. Then it gives you reassurance. And you're like, oh yeah, we are right. So let's go ahead and populate all these steps. And then you can finish your graph, okay? If I remember correctly, on the test, you do have step function graphs. And again, make sure you know that at the very least, come up with some numbers, okay? Then you could make a graph. I would not accept people to leave graphing blank because you can at least create some numbers. Okay, substitute in. So now we have a +1 outside of the step function. That means it is shifting up 1 unit. Okay, so So we have shifting up 1 unit. And as you are drawing, you can also spare some of your thoughts and say, well, let me see. Let me see if it's actually correct. You want to test it early on so that you don't waste your effort. Yes?
Up one is identical to left one.
In this case, it looks exactly, yeah, they will look exactly the same. Yeah, so it's just a narrative, okay? And in terms of the look, appearance, yes, you are correct. That is the correct assessment. So you're like, yeah, let's go ahead and try 0.5 again. All right, step function of 0.5 is 0, and then 0 plus 1, 1. So you can confirm that you are correct, okay? Now, I would tell you this, graphing is very important. I made a pretty stupid mistake when I was in math early on before calculus. I thought graphing is stupid. I think graphing is tedious. And after I started calculus in college, then I realized that if you know how to graph, life is easy. Life is a lot better if you know how to graph. So I'm just going to put it out there, okay? Making sure that I've said it, okay? So please make sure that you know how to appreciate graphing.